Hello all, good morning. This is Dr. S. Lakshmi, Assistant Professor in the Department of Mathematics, SNS College of Technology. This is a lecture video series on the course Multiple Integrals, and we are on to the topic of area and volume using double and triple integration. In the previous classes, we have seen problems regarding double integration, and practice problems were also been taken. Now, we are on moving on to the next method, wherein your definite integral will be having the variables. Definite integrals limits will be having the variables, as you can look on to this problem. This problem contains a double integral with the integrating value, and both the variables dx and dy here. So as you can see here, the limit contains, as you can see, the limit contains x squared here as a upper limit. As you can see, the limit contains x squared as a upper limit. So what you can do? What you can do for this kind of definite integral limits? So the concept is, you are just going to take integral 0 to 5, integral 0 to x squared, x into x squared plus y squared dy dx as usually. But since the limit contains variables, x and y should be the first integral. What should be the first integral? X should be the since you are having the definite integral, in the definite integral x squared as the value, you will have to have the first limit to be y. So what can we do for this kind of problem? Since you have x as the variable in the limit, you have to integrate with respect to the variable y. So what will we do? Integral 0 to 5 x squared into integral 0 to x squared, x cube plus xy squared. You have just multiplied these two things here and you have just put it. Now, what shall we do for the next step? We can just integrate it. You are integrating x cube is a constant. You are integrating with respect to y is your variable. So x cube is constant, so you will have y here. And since x is constant, you will have to integrate y squared. On integrating y squared, you will have y cube by 3. Within the limits, what your limits are? Y is equal to x squared to y is equal to 0. This is your limit. So the upper limit should be applied as x squared for in place of y's, and the lower limit should be applied as 0 in place of all y's in the problem. So what shall we do? We are going to apply y here, and for y here you will have to apply x squared as the upper limit. Since you have a lower limit to be 0, you need not worry about all the other things. You can notice that it will vanish. The lower limit will vanish. Now you will have to multiply this x cube and x square, so that you will have x power 5, and also you will have to multiply this x and x cube x square to the power 3, which will be x into x to the power 6, which is x power 7. So in the next step, what you are having, it is x power 5 plus x power 7 by 3 into dx. So on integrating, now we are going to integrate it with respect to the variable x. On integrating with respect to the variable x, you will have x power 6 by 6 here and x power 8 by 8 here. This 1 by 3 is the denominator here. Now upper limit is 5 and lower limit is 0. As usually we are just doing the problem. And completing it using a minor simplification process. Now what will be the value here? You will have the value to be 1 by 6 into 1625 plus 40625 divided by 4. On simplifying it, you will have a value. Using a minor calculator, you will have to do it. Now we will have another problem on double integration. Integral 0 to a, integral 0 to root of ay. So this is the change here. You have the limit. This is the change here. You have this limit as root of ay. So now what is the problem here? Xy into dx dy. So what you will take x, I is equal to integral 0 to a, integral 0 to root of ay, xy into dx dy. In the previous problem, the limit contains only x. The limit contained only x, but here you have both a constant and a variable here. Since the first variable is y, you have to integrate with respect to the variable x first. Since the first variable is y, you have to integrate with the variable x first. Now we are going to integrate with respect to x. So integral 0 to a will be the outer limit, and inner limit is integral 0 to ay, root of ay, xy into dx. On integrating with respect to x, what will be the constant value? Y will be the constant value, and integral 0 to root of a y x into dx will be the innermost term, and you are going to integrate this alone, not this y. Now what will be the value for integrating x? You will have x squared into x squared by 2 as the value. Now you have to just apply, in place of x there is root of ay, just root of ay. Therefore root of ay the whole square divided by 2 minus 0 square, this is lower limit will vanish as usually, and dy. Now we have simplified the problem with double integration to a single integration, wherein you have a definite limit as a constant. So you will get the value to be the constant answer in terms of a constant value. Integral 0 to a y into a y divided by 2 into dy. On multiplying it, you have y square, and a by 2 is a constant value. Just mere simplification, you will have the on applying the upper limit and the lower limit, you will have the value of the problem to be I is equal to a power 6 by a power 4 by 6. You are just simplifying using the single integration process. The only thing you need to notice here, we don't have any value, we have a constant term which is a. So we will have some more concepts and problems in the next class. Thank you.